Okay, let's do some math for fun. Welcome to my channel. Today I'm going to teach you how to do this beautiful tower, and the purpose of this video is to pass the mathematics to draw, and also in functions. Well, that's a little bit crazy, but I that's the fun fact of this video, and I want to share with you how to do that. So at first, I will erase these functions over here, and I am going to teach you how to calculate each of them. But don't worry about calculus with formulas and that things, because I create a constant formula, or I don't know, but I don't know how to call it, but it is a little bit crazy, because when we have these four functions, you are gonna all you are gonna also gonna repeat one another, and you can do many functions as you want, and they are not many. It looked like that it has like one, two, three, four, five, six functions, but the truth is that we are gonna only graphicate these four functions by flower. So let's get started, and I'm gonna teach you. Well, the first thing that you have to know is, well, as you can see, when I raised the functions, it was that each one have a parabola. But what about increasing the volume of the parabola? As as you know, let's suppose that we want to calculate the volume of this. You you have to know that. Well, let's put zero to one. Sorry, to one, and you have to know that it will gonna have uh, this like this form, and we're gonna put the one over here to the power 3 divided by 3 minus 0 all to the power 3 divided by 3, and then we only do the operations minus 0, and we have that the volume is 1 a I want a over 3, and so that's the thing. If we want to increase, we want gonna divide, we're gonna multiply this like any number. So because if we do this, we're gonna have 3 to the power x cubed divided by 3. Yep, by 3, and it will cancel on. We will have one that have and that we not don't have sense, because we want to increase the volume, the volume, yeah, the vol or the area. Sorry, the area of of that parabola. So we're gonna divide, as you can notice, to like, for example, a squared by 2. But what how do you know to what number we're gonna divide that x? If we have dx. Sorry, I forgot. If we wanna dx, so the thing is to pass it like rep, like repeat points. And what do I mean with that? Let's suppose y is equal to 1 and x is equal to 1. Yep. And we have like a repeat point. Well, I don't know how to call it, but it is like 1.1. And if we put y is equal to 2 and x is equal to 2, so and then let's suppose we put like here, so we want to pass over that values, and and that's the and that so that's the trick, that we want to pass in like doing these squares, these crazy squares. Because if we graphic like y is equal to 3 and x is equal to 3, we're gonna have like 9 squares, but well, these 9 squares, but well, actually they are not 9 squares, but if we count each one of them in each line, so we're gonna have 9. Well, you guys, right? So we're gonna pass each parabola by that point. Let me erase that. Uh, So the thing is that let me go to here, and we will have y is equal to x squared, and we want to pass 2.2. So we're gonna like it will gonna have like y is equal to 2 and x is equal to 2, right? So we're gonna substitute, uh, 2 is equal to 2 square, but it don't have sense. Like, 2 is equal to 4. That's incorrect. I know. Yep. So we're gonna divide, and we're gonna take this value. Sorry, this value that I put any letter, so we're gonna divide by 2, and it will and it will gonna have, we will gonna have 2 per 2 over 2, and it cancels that out, and we have 2 is equal to 2. And that's the thing that that we that we pass over that. So yep, let me erase this y, and yep, that's the thing. So we're gonna put x. Well, no, sorry. We will gonna have like this will be equal. Sorry, 0 to 1. That's no 0 to 2. Yeah, 0 to 2. So we're gonna have 1/2 a square dx. Let me erase these ones over here. This, and then we're gonna have 1/2 of x cubed over 3, and the thing. So well, that's the thing. So that's the thing. So we're gonna check if our calculus is alright. So we're gonna put a square divided by 2, and if we see, I am gonna calculate one. It pass in the point 2.2. So our calculations are correct, and we don't have to forget the negative one, that is x minus x squared divided by 2. And yep, and you may are asking, yep, you are, well, you may are asking, what about this function over here? And why did you say that? Well, what that did I say that it will gonna have four functions, not six functions? So here is the trick. I am gonna give you the function over here, and I am gonna explain you why, how did I make that. Uh, I'm gonna like erase those of them, and so check this out. See, if we put y is equal to the absolute value of x, and we put y is equal to x, and y is equal to minus x, we will gonna have uh, this function over here gonna take the half of each of these. So if we apply the square root in both sides, remember that the square root is also in this form that I write over here. And if we put like a one half, or the square root that actually it is the same, we will gonna have that. And if we other time, if we put the square root in here, uh, we will gonna have the both functions, but this time like in one function, and that it is like a little bit crazy because we let's suppose that we have x plus 2 is equal to 5. We on in only in this function, in this equation we're gonna apply the same uh, the same operation in each one of the members of the equation. And this time we only apply in three functions different. So that's a little bit crazy, and that's why I was thinking how to optimize the function. So well, that's that's the thing that I want to also I want to share with you. And we don't have to forget the uh, the negative form. We're gonna put a square root of the absolute value of y minus 1. Yeah. And what about the other to pass in this 2.2? What about this? Yep, the in here. So we are gonna do the calculus. So we're gonna pass in the 2 equal to 2. So in here, we are gonna copy the the original function that we made of that. But if we substitute like y is equal to 2 and x is wanna be equal to 2, we're gonna see that absolute value of 2. But we need like another number to of coefficient to to do this equality, and well, that is 2. So because it gonna have we're gonna have two is equal to the value, the absolute value of 2 square, and then we're gonna have 2 is equal to 2. So so here we have our other function, and obviously we will gonna graphicate the negative one. So that's the thing I need. And also in here we are you are gonna like remember that we want to increase its area, because if we integrate like y is equal to square root of the value of x to like 0 to 1, we were gonna have the absolute value of 1/2, and we're gonna add ones, and we're gonna write in this way, and this is equal to 3 over 2. Well, and you know the thing, if like we have a fraction over here, if we multiply it like any constant, we're gonna increase, because like let's suppose 4 divided by 1 by 1/2, it will be equal to 4 to 1/2, and this is gonna be like we will gonna have 8. So yep, that's a little bit crazy that we change the operation, the opposite one, and yeah, that's why I love mathematics. So we're gonna see if it works, and as you can see here, it works because it passes in point in to 2.2, and we don't have to forget the negative function. Yep. And well, that's the thing. If we want a or like a third petal, and it will gonna pass in the 3 point comma 3, and y it will be equal to 3, is equal to 3, and you know the thing, y is equal to a squared by any constant, so 3 is equal to 9, and we're gonna divide by 3 to do this true. So we have our function, we're gonna put minus a square over 3. What about the square root? Yep, the same. 3 is equal to the to 3, and we need this constant. Well, I'm gonna like substitute with also these numbers. So the constant of here is also 3, and that's why I say you that we don't need formulas, because we only have to apply the things that we learn in school. So 3 is equal to 3, and well, that's the thing, we put like a square divided by 3, a square is equal, yeah, well, y is equal to minus a square divided by 3, and so on, so on, so. Yep, you see, the flower, like it seems more beautiful, and we're gonna do the same without calculus because we made that. Let's put in here. Let's put 4x y is equal to minus square root of the absolute value of 4x, and so on, so on, so on. Yeah, you see, if we see here 4.4, 3.3, 2.2, 1.1. So what that's the thing, that's the constant that I was talking about in the beginning of the video, that we will wanna put the coefficient in each of them, and yeah, that's the thing. So thanks for watching. Don't forget to subscribe to my channel. Remember that I have another channel that it will have the same content but in Spanish. I will put you the link in the description, and don't forget to give a thumbs up and subscribe for my channel for more exciting videos. Bye.